Alright, this is my Anagrams program. It's available on GitHub at github.com/ Cyndi5. That's CYNDI and the number 5. And the repo is called Anagrams for some reason. Then we have our imports, which I won't get into. I'm only including them because I need them. But we'll see them in use later as we move on here. I want to go over the functions first, and then we can show how they come together. So we'll go over count letters word first. It counts the number of letters in a word, the number of each letter in a word. So the function name might could use some refinement, to say the least. So we initialize a dictionary. That dictionary is going to have a key, which is the letter, and a value, which is the number of occurrences of a letter. And also, if a letter just isn't in there, then it's not going to be in the dictionary at all in this dictionary. So if you only have the letters A, E, and R, then you'll have A and then a value of 1, a key of E, a value of 1, and a key of R, a value of 1. You won't have any other keys. So just to be clear on that. So given a word such as E, A, R, then you go through the letters in the word, which Python can split the word into letters if you specify 4-letter in word. If letter is in your counts, in other words, if it's already in the dictionary, then we're going to increment the count of that letter by 1. Otherwise, we're going to set the value to 1 because this is our first occurrence that we see. So naturally, that's going to be number 1. Now, we could have initialized them all to 0, but there's no need, as you'll see. And then we return the counts, that is to say the letters and the frequency of each that are in there at all. And then the next method, or next function I should say, is search strings, which will search an array of strings for only those words that have the same character frequencies in the given frequencies. Now, this is going to initialize an array called results because we're going to return the results. The parameters here are frequencies and strings. So the frequencies are the counts of letters of one word that you're searching for, or one set of letters that you're searching the dictionary for others that have the same set of letters and the same frequency. So anagrams of that set of letters. That's what this is doing. So we initialize the results to none, and then we go through each string in the list of strings, which would be the list of strings would be a word list being passed in the form of an array. So for each of those words in the word list, I guess I could call it, frequency, you count the letters, again, you count the frequencies of the letters of each, and the frequencies of each, and return that dictionary. So there's for a given word out of the dictionary, the word list, that you will have a certain frequency. And if that frequency matches the frequencies of the letters in the word that you're passing in, then yay, we append the results with that string that came out of the word list. And then we return it. Now, how do we get with those subsets of strings? Like I was talking about with the optional letters. Well, as you saw, I took out 1 of each, and then 2 of each, and then all 3. Well, this is pretty much doing the same thing And so here we have an empty array called result, which I could have called results, I suppose. And then we go through the list of numbers starting with the starting with I suppose 0 up through the length of that string that we passed in, which would be our optional ones. So that would be your d, x, and y in my example earlier in that previous video. So you will get all the subsets of those. So that would be dxy, dx, dy, xy. And then you would have dx and y at a minimum. And so that's exactly what this itertools combinations does, is it will actually find all the combinations of a given string, which is a set of letters, all the combinations that are of length I or greater, starting with 0. So you're not going to find words with 0 length of letters. So 1, you might have A and I. And then for I equals 2, you might have like AB, like abs. And then, that would not necessarily be in your word list, though. So you might have A, and you might have AD, like an ad, like an advertisement. So in my list that I showed in the previous video, if that were an option. But really, to be perfectly pedantic about it, that probably the A would not be there, because that's a required letter, because we're going to use this in a certain way. We're going to just get all the subsets of those optional letters, the string of optional letters. So dx and y. So again, like I said, dxy, dx, dy, xy, dx and y. That's them. So why then do I return reverse? Because we start at 0 and go to the range plus 1, because we have to add the extra number, which is going to be size 4 elements, for example. It's going to be 0, 1, 2, 3. So that's where we're adding the 1 to that, because we want to count 4 in the list. And then so for each of those lengths, we do the combinations of that length I. So starting at 0, and so then we append the combination joined with that empty string. And this is because when you are dealing with a result from this, you get an array of characters. So since an array of characters is not as useful to us as a plain string, then we need to do the join using the empty space. It'll just put like AER, which is an array, it would put it as AER. Or DXY is an array, it would put it as DXY. And then we reverse it because we want the longest words first. And that's how do you get the longest words when the minimum set is controlled? Well, you look at the one that's not controlled, and that you reverse it in length, and you'll end up with the same thing. Now here's the refinement of the set of results, which uses just a very simple parameter here. Simple, I should say. It's fairly simple. So we have to return a list of filtered words in the results. The results is over here. And then we will filter it by only the words for a given word in the results. We will filter it by those who match the number of who match the regex that you specify. And regex is first, word is second, and already match. Regular expression match. And that's pretty much all the functions. Now I have some helpful command line parsing here that helps us specify things in a nice clear fashion. And then that's those arguments, the arguments that you would specify would be, at a minimum, you need the minimum. So that's required. So you need dash minimum equals, like for example, AER. And then the optional string of characters to try, that's like the DX and Y. You pass that in. And then the regex, it has to match. The default is just blank. And then the next one is the word file. And the word file is the file to read from to get your words. Now on a Mac, you've got user shared dict words. So that would be actually looking for a dictionary full of words, one per line, that already exists, at least in my MacBook. And you could, like I say, download a list of words from probably just about anywhere, as long as it's a plain text file. And of course, go to a reputable source, and don't download anything you shouldn't, and you're doing all this at your own risk. But once you get those arguments parsed out, you have minimum optional word file and regex as your variables. I just put them into variables, and I print them out right here because I like to see what I'm doing. And then this, the help is kind of getting in my way. The pathlib.path word file .read text .split on the new line all together just reads the line, reads the list of words line by line, and splits it by the new line character, assuming each word is on a separate line. It reads the text from the file, splits it into an array of separated by the new line of words. So the words, if there's like however many thousand words in the dictionary, then the length of that array is going to be that same number. And then your optional combos is where we were getting all the subsets of the string, the DXY, the DX, DY, and XY. So you have optional combos. And then for each of those combos and those optional combos, combinations of optional letters that aren't required, then what you do is you concatenate. It doesn't really matter the order, so we'll just tack them on the end because they're going to be considered a set. So it's almost, you could think of it as a set union almost. But not really, because the letters can repeat. So it's not technically a set. So DEAR ARDXY would be the like the first combo, and then ARDX, and then AER DY, AER XY, and we would go on down to each of the combos. For each of the combos, we compute that. Now there is a case where the combo could be empty, and so you end up with just the minimum letters. That's why we call them the minimum letters. And then you search each against the word list, and it sounds pretty inefficient, and it is. But it ends up being pretty fast because it's just doing some pretty simple work. This doesn't even have any libraries included, any packages, modules. So if if there is a regex, then we're going to refine the results according to the regex, as we said earlier. And then if you have any results, then I put them where they categorize them by the target that you looked for, and then the results underneath that. And so if we exit out of here and look at our terminal, then we could run our Python command. Alright, here. And I've specified a lot of things here, but we'll go AER, optional, our DXY, and our regex. In this case, we'll start and end, and then between there we have 4 letters. And then this is a Word file I downloaded on also some site. I can't remember what. I think it was a site that dealt with words. But, I could have easily left this option blank, and it will by default search the user share dict words, which will be on, at least is on my Mac, and probably on others, and on Unix systems for sure, and Linux. So, if we run that, then actually we have quite a few. And you can see it found 4-letter words only, so we ended up with AERY, X, and D, which makes sense. And then, because it's a total of 4 letters, and so from just those 4 letters, it looks like there are quite a few possible anagrams. And so that is how it works. Let me know in the comments if you have some suggestions on how to refine the code, and also please do go to my GitHub site, and if you want to issue a pull request against my code base, I'm happy to take a look at it. Thanks a lot.